All right, so in this problem, we're talking about having two different parties. And we want to be able to kind of express their motion, and then we want to look at graphically so we can get an idea of what this means. So we're going to have two sets of parametric equations. One that's going to represent you and the rate at which you walk, which is 3 miles per hour, and the other one which is going to be describing your sibling, who is going in the same direction as you, riding on their bike at a rate of 5 miles per hour, but they're going to leave 30 minutes later. So if we're letting t be measured in hours, let's come up with our two sets of equations, right? So we're going to have you versus the sibling. So your position is distance equals rate times time. So it's just going to be 3 times t. And what we're going to say here for your y value, we can just say something generic because we just want to have a representation of your path as we crawl along the screen on the calculator. So let's say that that's just 2. Again, it can be anything. It can be 3, 4. I don't really care. Now your sibling. And we're going to use subscripts here, so x sub 1 and y sub 1. So then x sub 2 of t. So the sibling's rate is 5. However, it's not going to be 5 times t, because they are starting 30 minutes after you, right? So their time is going to be reduced by 1/2. Because they're starting 30 minutes later, right? And let's say that their y value is 4. Now what we can do is, we can compare these two and see what their graphs look like. Now, we can definitely take this as algebra and figure out when will they meet, meaning when are their distances from home being the same. In other words, if I take 3t and I set that equal to 5 times t minus 1/2, what am I going to get, right? And so the algebra would be, so 5t minus 5 halves. If I subtract the t over, so that's going to be negative 2t equals negative 5 halves, solve for t, and I get 5/4, which means that in 1 hour and 1/4 of an hour, so 1 hour and 15 minutes, your sibling has caught up to you. Okay, but let's see if that works out right in our graphing calculator. All right, so we're going to represent u by 3t. And again, this is just a throwaway number. Just make it 2, that way we can see it. And then for your sibling, it's 5 times t minus 1/2. I'm going to make them equal to 4. So for the window, it looks like we're only going to like maybe 1.5. So let's go 0 to 1.5. Make this really small. The x-min is 0. The x-max, so you're only going to be walking for 1 hour and 15 minutes. So let's say 5 miles is the farthest you walk. And then for the y-min, of course, is 0. Let's go to 5. So we're going to have each of you with your own paths, right? Now let's graph this. So there is you. And then there is your sibling. Too bad it can't graph these at the same time, right? All right, so here's what we can do. If we trace along here and we say you want t equals 1. What? Okay. All right, so let's go to the table setup. We're just going to do it this way. For the independent, let's do ask. Now let's go to the table. So at 0, you haven't gone anywhere, and your sibling is, well, they haven't started yet, so it's really kind of tough to say for them. Whenever you get to half an hour, you've gone 1.5 miles, and your sibling is just starting. At 1 hour, you've gone 3 miles, your sibling has now gone 2.5 miles. If I go to 1.5 hours, your distance is 4.5 and theirs is 5, so they clearly have overtaken you. If we back it up and we set an hour and 15 minutes, so 1.25, that's when your distances are going to be exactly the same. So again, it would have been nice if the graph would have allowed us to graph them at the same time. I don't know if there's a mode for, here we go. We're going to do simultaneous graphing. Now let's see what happens. So here you are walking. Yes, see, here we go. Oh, by the way, you can hit the enter button to pause the graphing. All right, your sibling in red is starting to catch up, right? They're catching up, they're catching up. And now they've met you, right? And now they said, so long, sucker. And they just keep on going without you. So that's pretty cool. Totally forgot about the simultaneous graphing. I'm so used to doing sequential graphing. It graphs one, it graphs the other, and you're done. Anyway, hope that made sense for you. Parametric equations are super useful. You can do a lot of really fun things with them. And I suggest that you come over here and just play around with stuff, right? Like we talked about how we could turn an ellipse into parametric equations. What if I do sine of t and cosine of 2t? Not all that exciting, right? What if I make this 3t? Ooh, right? Oh, this is my problem. I should be going from 0. It's going 0 to 360. Yeah, I don't know. It's just kind of fun sometimes to just mess around with this and see what you get. And what's the worst you can do? You're not going to break your calculator. If anything, just come back here and go second, memory, 7, 1, 2. We're all clear. Back to the very beginning.